Hello everybody, here we are, and it's time to just simply revise the stuff. Throughout the like in the morning we completed that SQLi section, and here we are to just simply get the remaining things done. So we have already gone through this V8 engine, Orinoco, turbofan ignition, and GIT. We've talked about this processing at scale and is not just single threaded on. This is something that we've already discussed, so we are not gonna be discussing it right now. The next section that comes right here, that is internals of libuv and event loop. Even we are sort of well aware of it, so we'll be just simply going through it real quick, then let's see what's gonna happen. So coming back to this particular thing, when it comes to ultimately what exactly happens, let me show you a diagram. So event loop, node.js, just a minute. So this is what actually happens. So at the end of the day, whenever you make any request, and when that request comes, and before even that, whenever any request comes and the code runs, and if that code gives a callback, so suppose if you are making reading a file or making a db query call or any REST API call, so at that time if there is a callback, so once that particular so what event loop does, event loop is the master thread over here. So it just simply runs the code, and whenever there's a callback, and ultimately before even a callback, whenever you read something or do something that is time consuming, so it just simply kind of offload that tasks to the libuv worker thread. So this is the event loop is the master thread. Similarly, libuv has 4 worker threads by default, so it will just simply event loop offloads the task to them, and once the task gets completed, then event loop just pushes those callbacks to the event queue, and from the event queue it just simply pulls those callbacks and pushes sends them to the callback stack, and over there they are just simply processed. So this is how it's just simply done. And apart from this particular thing, we'd better just simply go through it, read it and all. Talking about the queue, so we have timer and we have pending callbacks, we have idle, ignore, poll, check. Mainly there are 2 types of queues we have. First one is called micro task queue, and second one is macro. So this is how it just simply goes, and you can, and there are many layers of it, so you can just simply read about it. Having said that, I myself need to know more. Coming back to this one, and libuv library powers async processing in Node.js. Async processing in the sense something that is asynchronous in the sense that just simply what it does, that has a callback in all. Ultimately, what is asynchronous in Node.js? What is asynchronous in Node.js? It's no use guessing the thing, so I better just simply know the proper definition. Before even that, I just forgot to turn off the chats and all. What is this? Probably it got scheduled by mistake. I don't know, or I didn't even cancel it. Who knows? Let me just simply delete it. That would be better. And apart from this particular thing, this 25 seconds video, things are crazy, but never mind. So I'm gonna just simply continue with this one. This and yeah, everything's set up. Now without any further delay, let's simply get going. So what I was just simply saying, that in Node.js, asynchronous programming means executing tasks without blocking the main execution thread. So the main execution thread doesn't get blocked. That doesn't mean that the function process doesn't get blocked. So in Node.js, asynchronous programming means executing tasks without blocking the main execution thread, that is the master thread, of course. When Node.js starts a heavy input output IO operation like reading a file from a disk, requesting data from an API or querying database, it triggers the operation in the background and immediately moves to the next line of the code. So ultimately what it does, it triggers the operation, means event loop ultimately runs the whole code, that's the master thread. So master thread runs the whole code from top to bottom, and if there's any IO operation, or if there's any request from an API, so just simply offload that task to the thread pool. There are libUB has 4 thread pools by default. You can increase and decrease the number as per the configuration, of course as per your choice. By default it has 4 thread pools. Those 4 thread pools are ready to just simply handle the request, ready to handle asynchronous requests. So they take the request and then they just simply process that. So if that is a reading request, reading a file request, they will read the file. If that is that has to do something with the system, they will do that. If that has to do something with the processing stuff, they will do that. If that has to do something with making a request, an API request, that will, those threads are gonna do that. And once the particular request gets processed, then event loop already knows the callback, so event loop just pushes the callback to the event queue. So this is what actually happens. And okay, there are many things. So this is it. We have to go through many things. We have to revise a lot of things. So let's just simply continue. libUB provides a lot of important functionalities. The first one is the networking capability, TCP, DNS resolution, UDP, etc. Node.js, DNS, that is it. File input, output, we've already talked about it. A pool of worker threads to handle the thread specific CPU, that is also true. Worker threads. So it ultimately what happens that how can I put it in words? Just a sec. V8 engine, Node.js V8 engine. There should be a better picture here. Yeah, so here we are. So ultimately libUB has the event loop. So libUB has two things. I hope I'll be able to do it. Okay, so ultimately over here we have the application. V8 engine just simply runs the code, but before even that application, the code is run using a V8 engine, and ultimately event loop just simply runs it from the top to bottom. That's sort of the master thread. So master thread runs that, and once there is something called asynchronous, so that is kind of offloaded to the threads, these worker threads, and there are 4 worker threads by default, and they do different types of things depending on your need, of course. And after that the callback is actually pushed to the event queue. So this is actually happens, but all these things, event loop and worker thread, they are the part of the libUB. So ultimately if we talk about Node.js system, so it has V8 engine, it has libUB, it has even Node.js binding layers. Ultimately this is the layer that just simply binds V8 engine and the libUB. So this is how it simply goes on, and there are tons of like a lot of articles on this, so you can just simply go through that. Facilitates creation of child processes also. Such a good thing, child process. So that simply means you can create child processes using what? Using libUB. So libUB just simply gives that provides that feature. The thing is that, does libUB helps cluster create child processes? Because there is something called cluster in Node.js. Using that you can create a you can actually fork the cluster. So yes, libUB handles the low level heavy lifting required to create and manage child process. So that's really great. There is something called cluster. What is cluster? This is another module by Node.js, because Node.js is a JavaScript is a single threaded language. That simply means if you have 4 threads, so JavaScript is gonna run only one of them. So if I just simply try to draw it, it's gonna be really great. So just a minute, I hope it's not gonna take a lot of time. So when it comes to JavaScript, so suppose this is my CPU, and over here I have actually, what the hell, suppose I have 4 threads. So this is how I have 4 threads. But the thing is that JavaScript by default is a single threaded language. So even if I have a server running, suppose I have my Node.js server running, so that Node.js server is gonna run only on one of the cores. So it will run only one core. So if I have 4 core in my CPU, it will run only one core. Then cluster comes in into the picture. So what this cluster does, cluster forks the process. So it will create as many processes as there are, as many child processes as there are CPUs. So if I have 1, 2, 3, 4 CPU or CPU cores, so it will fork four clusters. That simply means it will create 4 child processes, and those child processes are gonna run the same program. So the same program is gonna be running on all these child processes, and the cluster is gonna sit on the top. So cluster will have a primary cluster. So there are gonna be two types of clusters. There's gonna be primary cluster that is gonna be responsible for forking. So the request is gonna come to the primary cluster. From the primary cluster, the load will be auto balanced. Sometimes the load will go to this one, then this one, then this one, then this one. It will just simply keep hitting the different ones, and this is how it just simply goes on. And there are different types of algorithms. There is a round robin algorithm. There is a first in, first out, first in, first served, FIRST, first in, I think first served, something like this. And there can be many more. Even I forgot about some of them. You can know more about it in the HLD section. We may be going through it right now. That's not the focus, but let's do one thing. Which algorithms cluster module uses to load balance the request. So load balancing algorithms, when it comes to cluster module, so it uses the round robin algorithm by default, distributing incoming connections among its worker process. So that's good. Cluster uses by default round robin. Apart from this particular thing, we have shared there can be many more as well. Load balancing algorithms, let's just simply have a look at them. So when it comes to load balancing algorithm, so there is round robin algorithm, and there is a weighted round robin and source IP hash, least connection method, and least method time method. First one, round robin, is clear exactly what it is. Round robin means one by one it will just simply keep balancing the node. It will keep sending the traffic one by one to all servers. Weighted round robin means it just simply checks the weight, weight in the sense how heavy that server is, or how capable that server is. On the basis of that thing, it load balance the request. Source IP address based on the IP of the machine. Of course, it just manages that. Least connection method. Least connection means whichever has the least connection, it will send the request there. Least response time method, whichever takes less time to response, the request will be sent there. Even there are more. These are not all the ones, because I learned them in my HLD section. Unfortunately, I could complete only HLD, so not this year. Somewhere I completed that HLD system design. So somewhere here, load balancing, load balancers, I talked about this stuff as well. So let me just simply go through that really quickly. So I think this is the one. Yeah, here we are. So over here, when it comes to algorithms of load balancer, so there are two types. First of all, static type, and second one is the dynamic. Static means those which do not change, they are not dynamic. The request comes, and that's based on the algorithms that's sort of load balanced. And when it comes to dynamic, so they just use dynamic values to just simply calculate the stuff and all. On the basis of that thing, they load balance the request. So we have the round robin algorithm, weighted round robin algorithm, that's pretty simple. IP hashing algorithm, I think these three were mentioned there as well. Least connection method, that's pretty simple. Weighted least connection method, this wasn't mentioned over there. Weighted least connection in the sense it checks the connections plus the weight, so the number of connections and the weight and all, something like that. Least response time, pretty simple. Resource method, it uses actually agents. So suppose if you know about what is they are called, Grafana and Prometheus and all. So ultimately there are some agents that tell you about how much load those servers are actually handling. On the basis of the info given by those agents, you just simply decide whether how should the load balancing happen. This is how it just simply goes. By the way, load balancer, there are different kind of load balancers. Application level load balancer, network level load balancer, global server load balancing, DNS, even DNS, domain name system or service. What is the full form of DNS? Domain name system, yeah. So event DNS has the load balancers, and application level you must have used that, and even network layer has that. Okay, enough of these things. Let's continue where we just simply stopped. Alrighty, so we've gone through this particular thing, event loop and network IO. Okay, that's simple, easy. What is the next thing? And there is something called simples. Okay, handle and requests. Handles and requests. So in Node.js there are two things. First one is handles, and second one is request. What is handles and what are requests? So handles are, let me just try to think of it. So handles are long running sort of processes. I cannot be correct here, so excuse me for that. I'm just gonna be just simply googling it too. So handles are long running or long time processes and all that handles something that takes time. That's really bad example. Requests, they are not, they are short time processes. I don't know what they are actually, but they have short time, so their kind of lifetime is short, and they take care of something that doesn't take a lot of time. Coming back to this thing, requests, request versus handles. So especially when you make API, let me see, I mean, what is the use of guessing here, right? So in software development, requests are the message. Nope. In Node.js, network issue. Okay, doesn't really seem to be facing right now. Okay, so I'll take duration operations, whatever, and reading the writing of operation. So now how can I? Okay, so ultimately when you set TCP connections and network stuff happens, at that time we use handles. Otherwise, when reading the files, at that time requests are used. Hopefully I'm not facing a network issue. Coming back to this one, in Node.js, handles and requests are two distinct abstractions provided by libuv. The underlying C library is responsible for event loop and asynchronous IO, whatever. And while a handle represents a long-lived resource capable of performing operations while active, a request represents a short-lived transient operation that often executes on or alongside a handle. Alrighty, so ultimately handle is a long-lived resource or object. Request is a short-lived. Handle represents stateful active IO object. Request represents a single or finite action until explicitly closed, active until the specific callback finishes. TCP servers, UDP sockets, timers, signals, file read, DNS lookups, and TCP writes and all. So okay, that's fine. So ultimately, handles, long-lived objects, they are active until they are closed, and they are persistent, and they are used for TCP connections, networking connections, and probably in timers and all. And when it comes to requests, they are short time objects, and they are not persistent. They are active as long as the work is being done, and mainly when you are reading the file and doing DNS lookup and all, at that time they are used. Alright, I know I'm gonna forget it again, but okay, never mind. Okay, so this is how it just simply goes. And apart from this particular thing, promises we know, timers we know, ticks we know it. What are ticks? Ticks is nothing but what is ticks? So ultimately, what event loop does, that it just simply what it does, it takes the callbacks from the event queue and sends them to the callback. Callback just simply processes that, right? So this whole process, this whole flow is called one tick, and there is something called next tick. So before anything starts, that next tick runs. So we are gonna be even going through that. So this is how we are gonna be going ahead. It's gonna be, hopefully it's gonna be quick. So okay, next end phase of event loop, we are gonna be just simply going through them, and I think everything's covered here. So one trick. So one, just a minute before even that, let me just simply close all these things. Otherwise, I'll keep saying one and nothing will happen. Coming back to this one. So ticks, what are the ticks? One full trip or iteration of the event loop. So when the event loop runs fully, that is called one tick. And there is something called a tick in Node.js refers to execution of micro tasks before the next iteration of the event to be starts. So it's like before the next iteration actually starts, that one iteration is actually called a ticker, and there is something called next tick, and this process.next tick actually runs before the next tick. The function takes a callback by invoking process.next tick, and we instruct Node.js to invoke this callback at the end of current operation before the next tick. So this is how it just simply goes on. So ultimately, I actually have some examples over here, so let me just simply show you those examples. SRP means single repository principle. Let's talk about this one. I'm even gonna be pasting it, that would be better, but how and where? Good question. How and where? Here we are, learning, testing, all that. Literally inside testing I've done this much. Never mind, this is gonna be what? This is I forgot, Node.js stuff. Line, as simple as that. It needs to be deleted later, so we are gonna be deleting it for sure. As for right now, alright, here we are. Now let's just simply copy and paste. Even I want to read this whole thing, like I'm not well aware of the. I know that there are micro tasks queue, and then there's something called micro and all, but okay, never mind. Touch index.js, and even we can say it then. Okay, let's code index.js. It's gonna just simply open, paste it here, and node index.js. The first one is the process tick 1, process tick 2, and whatever. Let's see. So what actually happens over here? Promise.resolve.then, it just simply gives a callback. This callback is gonna be pushed to what? This callback is going to be pushed to the what is that called? Micro task queue. And then we have process.nextTick, so it's gonna run at first. So ultimately, before a process starts, this particular thing runs. And then we have set timeout. This will be pushed to the micro task. So this callback will be sent to a queue. This callback will be sent to a queue. The task, it will be sent to micro queue if I'm not wrong, or micro task queue, just like this. And this one will be sent to micro. Hopefully it's right. I'm not sure about the name, but hopefully it's sent to the micro task queue. And ultimately this one, the first one, has the more priority than this one. So that is why, first of all, next tick is process. So this is the first one, this is the second one, and then this one has the more priority. So this is the third one, and this this set time one has the least priority. So this is the last fourth one. So this is how just simply done. But I'd better just simply really quickly go through an article. That would be better. Alrighty, here we are. So looking for an article that can explain me this thing well. Even the same thing we have here. It's pretty simple to understand, but naming is really good. Otherwise, how will you answer in your interview? So suppose we have this. First of all, master thread will start running it from top to bottom. As master thread runs it from top to bottom. So first of all, this promise.resolve will run. Okay, as this is a promise, so this whole callback will be just simply pushed to a queue. And after that we have process.nextTick. This will be, even there is next tick queue as well. So this will be sent to the next tick queue, and first of all next tick queue is gonna run, and set timeout will be sent to the queue as well, and then process.nextTick, it will also be sent. Now event loop will check whether nextTick has callbacks. It will find that okay, nextTick has 2 callbacks. So first of all this one will run, and then this one will run. And then after nextTick, micro task comes. That simply means it will check, event loop will check in the micro task queue whether it has the callback. So it will find that yeah, it has 1 callback, and then it will run this. As soon as this particular callback is processed, so this log is gonna be logged. So this is gonna be the third one. Then process.nextTick, again this is gonna be pushed to the micro task queue. Then event loop check again. Does it have any next tick callback? It will find yes, it has. So this is gonna be the fourth one. Lastly, the number of set timeout it will come, and the callback of the same set timeout come, and it will just simply process that. So that is why it is the fifth one. So overall, things do make sense, but when it comes to explaining it to somebody, even naming those queues, it gets hard. So article, what can I name it? Node.js event loop queues article. Here we are. Node.js event loop, a dive deep. I think this is gonna be a better one. Let me have some water first. This one is gonna be better. Hopefully I haven't read it yet. I hardly read, so forget about having read. Yeah, I haven't read it. Okay, this is, let's just simply go through it really quick. It doesn't really take a lot of time, hopefully. Node.js is a single thread, but somehow handles thousands of concurrent connections without breaking a sweat. How? Oh, okay, the answer is there was a mosquito. The answer is the event loop, deceptively simple mechanism powered by operating system itself. This article unpacks every phase, explains. Okay, fine, it's gonna explain the big idea: offload, don't block. Yeah, it just simply offloads, gives the work to the others. So most runtime handles concurrency. Most runtimes handle concurrency by spawning threads, one per connection. That's right, one per request. Node.js takes a different approach. It uses a single thread, but handles all in IO work to OS kernels via libuv. It's cross platform async IO library. Okay, the OS is already exceptionally good. Okay, never mind. Good at the juggling many IO operations simultaneously using mechanisms like epoll. So ultimately, what happens that the operating system or ultimately what happens that or any operating system, if that is Linux, that uses epoll, if that is Mac OS, that uses KQ, and if that is Windows, that uses another one. There's another one that is used by Windows. So ultimately these are used for just simply handling the IO operations simultaneously. Okay, Node.js just sits back and asks, let me know when something is ready, and once that is ready, just simply gets the callback and processes that. That's the event loop. It continues it is a continuous cycle that checks for pending work, runs callbacks, and sleeps when there's nothing to do without spinning the CPU. The 6 phases, each iteration or tick, that is what is called tick, of the event loop moves through 6 distinct phases. The first one is gonna be the timer phase, then pending callbacks, idle prepare. I think this pending callbacks has the callbacks and all. Okay, never mind, we'll see. Idle prepare, poll, we have check, we have close callbacks and repeat. So good stuff. Timers, pending, idle prepare. Hopefully somebody is not gonna ask this in the interview. Between each, who's gonna remember that? Between each page, Node.js drains the micro task queues. Between each page, Node.js drains micro task queues. The question is, where are micro task queues? By the way, micro task queues, in micro task queues, promises are pushed. Timers, executes callback registered with set timeout. So this is a timer's queue, and when a callback is executed, just like when a timer is executed, like set timeout and all, so its callback just simply go in this particular queue. So set timeout, set interval, whose delay threshold has passed. So this particular callback is gonna be pushed to the timers. An important nuance: the delay is a minimum, not a guarantee. If poll phase is busy processing IO, 100 milliseconds, timer may fire at 110 milliseconds or later. Node just doesn't preempt. What English? I'm really bad at this, but okay, never mind. This is the word I'm seeing for the first time. So preempt, whatever this is called, running calls to honor timers. Okay. A set timeout function sets 1 millisecond minimum internally. It does not mean run immediately. As you will see, set immediate is often the better tool for that intent. Set immediate will just simply make it to be called immediately. pending callbacks. First one is done, that is timers, and the second one is the pending callbacks. Executes IO callbacks that were deferred from previous loop iteration. They are typically error callbacks that couldn't be processed immediately. For example, what is this? Error connection refused. Errors from failed TCP connections, which some OSH report asynchronously rather than at the point of the call. This phase is really something application code needs to think about directly. Okay, so that's simple. Uh, Pending callbacks, if something hasn't been processed here from here, if something's left, some errors are left, they are just simply handled here in phase 2. Let's go to the third one, idle and preview. Used exclusively by Node.js internals, libUB. So it is mainly used for libUB, not exposed to the JavaScript. libUB uses this window to bookkeep file descriptor, watchers, and prepare the data structures. It will hand to the OS in the upcoming poll phase. Okay, went over my head. Used exclusively by Node.js. My pronunciation is crazy. Used exclusively just a sec. Pronunciation, I need to work on this as well. Pronunciation of exclusively.
Exclusively.
Exclusively. Okay, let's pronounce it like this. Exclusively. Am I learning English here? Never mind. So used exclusively. Used exclusively by Node.js internals, libUB, not exposed to the JavaScript. libUB uses this window to bookkeep file descriptor, watchers, and prepare the data structures. It will hand to the operating system in the upcoming poll phase. Skip it, your code never runs here. Thank you. Next one, poll. So these things, timers, pending, idle. The next one is the poll. Ultimately, what is poll? Poll is that that comes actually between let's just simply go through it. This is the most important phase and the one that makes node's non-blocking model work. Two things happen here. Execute IO callbacks, blocking, waiting for a new input. Okay, let's see. So any callbacks for completed IO operations, reading file, receiving TCP packets, are queued and run. Block, waiting for new input. It's going over. Never mind. Block, waiting for new IO. If no callbacks are pending and no timers are imminent, Node.js calls into the operating system, equal wait Linux or KQ macOS. This is a blocking syscall that puts the process to sleep, consuming 0 CPU until the kernel signals that a file descriptor is ready. This is the key insight. Node.js doesn't poll the operating system repeatedly. It goes to sleep and the operating system wakes it up. 0 CPU uses while waiting for a network response or discrete. Okay, the poll phase will exit early, moving to check if any set immediate callbacks are queued. This is something we'll have a look here, and let me just simply go through my notes as well. Otherwise, it's gonna be even a bit hard to understand. Coming back to this one, this is pretty much simple. We have next tick at the top. After that, we have micro task, and just even at last we have micro task, and in between we have event loop. It just simply keeps running the same way. Even we have timers here. So next take micro task, and then the timers are there. Timers has the least priority if I'm not wrong. Micro okay, timers queue. Should I just simply go through it? Micro contains multiple queues, that is right. Micro tasks, so ultimately micro tasks, they contain multiple queues. First one is the timer queue, and second one is IO queue. That is amazing. Second one is the IO queue, and input output queue, of course. So callbacks in micro queue executed after every timer callback in timer queue, and even before micro task queue we execute the next okay, that next tick is executed, that is fine. Callback Node.js this, and at the end of the next tick we have micro task, we have timer, and this the timer, this IO input, this is actually called macro task queue if I'm not wrong, and that is great. Next micro, timer, IO. Then just after IO we have polling, that just simply checks something. What? uh, this is something I forgotten. What does the polling check? And then at the end we have closed. What a person I am. I forget the things easily. I mean, everyone does. I think there is something called set immediate, and what this set immediate does, first of all, we have next tick queue, then we have micro task queue, then we have macro task queue. This macro task actually consists of timers, it consists of IO input callbacks, and it consists of then there is something called polling it in between. So what happens? Yeah, IO, after IO there is polling, and after polling checking, and then closed. So then actually polling happens here in between, so somewhere in the middle polling happens. What is the use of polling? I'll see. And then checking, and then closing. So this is just simply closed. So this is how this simply goes. Coming back to this one, first of all poll happens, then checking happens, and after check timers, pending, idle, poll, check, close. So this is how it just simply goes on. Polling is the important one. Ultimately set immediate. So ultimately what actually happens that I need to read it really carefully. This is the most important phase and the one that makes nodes non-blocking model work. Two things happen here. Execute IO input calls, IO calls, any callbacks for completed IO operations, reading file, receiving TCP packets are dequeued here and done, that is right. Then blocking, waiting for new IO. So if no callbacks are pending and no timers are imminent, Node.js calls into the OS, node calls into the operate OS with equal wait or KQ. Okay, this is a blocking syscall that puts the process to sleep, consuming 0 CPU until the kernel signals that a file descriptor is ready. This is the inside key. Node.js doesn't poll, okay, it goes to the sleep and OS wakes it up. So ultimately polling means it is informed by the operating system that okay, something is there to just simply handle. 0 CPU uses while waiting. The poll phase will exit early, moving to check if any set immediate callbacks are queued. That's pretty simple as well. So at that time what actually happens that first of all the timers are gonna run, timers callbacks, then IO, then after that polling will happen. Polling in the sense after that after the polling it will check with if there are set timeouts and all, it will just simply process them, and then it will just simply close. So again I'm gonna watch some videos on hopefully I'm gonna be able to find as well. I was watching these videos today on on cluster, of course. I mean, when you have to pass time, just watch these videos where you don't have to keep anything in your mind. By the way, he explained really well this particular stuff. Anyway, coming back to this, what do we have to do? Node.js event queues. So yeah, there are videos. That's gonna be whenever I'm gonna have some food and all, at that time I'm gonna be watching these videos. That's gonna be pretty amazing. Like this one, I mean, especially the ones which have diagrams. I like those videos a lot. So it's gonna be pretty amazing. Let's continue to the next one. By the way, this particular stuff is done, and Allah, am I crazy? I zoomed it too much. Alrighty, so overall things we are done. These are the two examples. They are pretty much easy peasy, so that is why it's no use. Just I mean, I talked about them as well, and these are some of the links of the articles. Even this next tick by Node.js, event loop, complete visual guide. Let's simply go through this as well, and that is it. Coming back to this, hopefully I'm not facing the network issue. Turns out I am. Oh, hey, how long? Is my mobile not nearby? It should be fine. I hope it's gonna be alright soon. Coming back to this one, understanding process.next tick, you can just simply read about it. It is just simply processed at first, that simply it has the highest priority, and then complete visual guide to understanding the Node.js event loop. Let's see what all is discussed here. I think I have gone through this particular article. Well, I haven't. What is the event loop? How many things are discussed here? Crazy. At least the OBS is not facing the network issue, just Chrome is going through it. So coming back to this, it has what all, everything starts from where. So first of all, we have micro task queue. Okay, but even before that we have timer. So we have the timer, after that we have micro task queue. I do not understand this diagram. We have timers, we have IO, we have, after polling we have check queue that just simply runs set immediate callbacks. That is fine as well, and then it just simply closes that. There's how to understand this. We have process.next tick. So this is the one that runs, that has the highest priority. So this run first. After that, promises have the like priority. So ultimately, in a sense, they are the part of micro task queue. Understandable. And this run first, then this runs. After that, what happens? After that, timers runs. After timers, the IO input queue runs. Then after that, after polling happens. After that, IO polling in the sense when reading, when master thread offloads the task of reading to the worker threads of libuv. So that libuv handles the job of reading, and once the reading is done, so at that time, maybe because of the of course because of this IO polling, the Node.js comes to know that okay, the work is done, and at that time it just simply takes the callback from here, this IO callback queue, and just simply sends those callbacks to the Node.js call stack, and over there they are just simply processed, and then check queue happens, set immediate callbacks, and then closing, and then exit. Okay, I should be going through this particular article as well, but it's gonna take time. Hence, at least for right now, we are gonna skipping it. Probably I'm gonna watch some videos on this that will make more sense. Okay, let's guess this. Which callbacks runs first? We have set timeout callback. This we have promise callback 2. We have this, and this. Let's try to do one thing. Set timeout will go in the timer section. Promise will go in the promise section. That simply means micro task. Process next tick will go in the next one that has the highest priority. FS read file, it comes after timer, and set timeout immediate, it comes after even timer. So this is the first. Which one is gonna be the first one? CB3. This should be the first one, and then promise, this should be the second one. Then set timeout, this should be the third one. FS read file IO input, this should be the fourth one, and set immediate, this should be the fifth one. Probably. I mean, now how to check where are the answers? Has he given the answers? Where are the answers? Come on. Otherwise I have to write it on my own to just simply check it. Literally gonna give it to the ChatGPT really quickly. Okay, let's simply, and here we are, and let's simply paste it here. Which ones give me the order of the execution execution of the callbacks. I think it's gonna take time to just simply even load the image, but okay. Come on here, how long will you do? Thank you. Done. Alrighty, so here we are. So execution. First of all, process next tick, then promise, then set timeout. So far so good. What is the next one? Aila bhai, ho ja. Then set immediate and file load. Wow, this is where we made a mistake. Why? This is the polling thing that I was even confused about while reading. So after set timeout, actually set immediate runs, and then polling happens, and then ultimately what actually happens over here, that not this particular section actually, I had this is where I had a look. So actually what happens, that over here, even polling before that, it doesn't make things clearer. So here we are. So ultimately what happens, we have timers, we have inputs, IO callbacks of course, then we have polling. The thing is that when it comes to reading a file, so it's not necessary that file is gonna be read really quickly. Hence what happens, that first of all, the timer, all the callbacks are gonna run, then it will check if there are any callbacks inside this. If there are not, it will just simply run this, and anyway reading takes time. So whenever the operating system tells Node.js that okay, the job is done, then only it's gonna look for the callback. So I think first of all timer is gonna run, and after that it will directly run anything with the checking stuff. So it will run set immediate, and after that this IO callbacks are gonna be running. I think so. Let's go through the explanation, but there's a catch. fs.read file. Why? Synchronous code runs first, so the above registration happens immediately on the call stack. After the call stack becomes empty, Node.js starts processing queues. That is right. Process.nextTick. Node.js has a special nextTick queue. That is also right. This is a drained before. This is drained before promises and before moving to the another event loop phases. That is also right. Promise micro task. Promise resolve callback. Promise callbacks are placed in the micro task queue after the next tick queue is empty. So after they are empty, they are just simply even processed. Then we have timers phase goes into the timers phase. That is also right. Poll fs.read file. The file read is performed by libuv thread pool. When it finishes its callback, enters the poll queue. Poll queue. That exact timing depends on the disk speed and system load. And makes sense. Poll queue. Check phase set immediate runs in the check phase. Okay, fine. Important interview question can be ki set timeout 0 versus set immediate. So set timeout this and set immediate this. The order is not guaranteed. The order is not guaranteed. Why? This is the timer one, this is the check one. So in that case, usually timer ones, they have the higher priority, don't they? So could be timeout, could be immediate, could be immediate, could be timeout. Why? Inside an IO callback, we have fs.read file. It just simply reads the file, and once the file reading is done, we are inside the callback. We have these two. So suppose the file reading is done, okay, then polling happened, and once the polling happened, Node.js came to know about the processing stuff that's done now, and after that we have timer and we have immediate. So at that time, this will be pushed to the timers queue. This will be pushed to what? Checking. So output is always immediate and timeout, because that is right. Why is this right? First of all, it will be pushed to the timers queue. After that, after the file is done, it will, that's such an interesting thing. What is gonna happen here, that first of all, polling will happen. So ultimately Node.js will know about that okay, the file has been read. After that, it has to process ultimately it has two more callbacks. The first callback is gonna be pushed to the which one? Of course, a timers callback, but this checking will still happen, and second one is pushed to the checking. Second one is actually pushed to checking callback if I'm not wrong. And because after polling it still has to just simply go through checking and closed, hence set immediate will run after that, and then it event loop just simply will go through one more tick, and at that time timers are gonna be performed. Let's go through the explanation again. So output is always this, because after the poll phase completes, Node.js moves directly to the check phase. So that's where set timeout runs before the next timer's phase. That is right. More precise answer for your image. The only guaranteed order is CB3 next tick and CB2 promise. After that set timeout immediate and all can vary depending on whether the file read has completed on event loop timing or not. Alrighty. So CB3, then CB1, CB5, but the CB4 may appear before CB5 if the input-output operation completes quickly enough during the event. So CB5 may appear before, CB4 may appear before CB5. CB4, what is CB4? Callback 4. Just a sec. So this is the CB4 file read. So it may appear before. Makes sense. Ultimately it depends on your machine, right? So coming back to this one, so suppose first of all next tick is gonna run, then micro task are gonna run, then micro task queues are gonna run. So first of all we are gonna be going through the timers. Now this IO will not run. Why will it not run? It depends whether its callbacks are gonna be executed or not, because this is related to the reading a file. So the task will be offloaded to the operating system, then operating system will read the file, and then operating system will inform your Node.js that okay, it will poll the Node.js that the task has been done. So if there are no callbacks in this particular section, so checking is gonna run, and then it's gonna just reiterate if I'm not wrong. And if once it actually gets informed, so at that time this particular section is gonna run. So either set immediate, and then so ultimately then this particular callback, or this callback then this particular callback. I still need to watch some videos on this to be even clearer about this concept. So what was the last? Summarize the polling section well. Where is it busy? I think I do not have a good network connectivity. Never mind, hopefully it's gonna just simply come on, yeah, just stop. We'll see. Coming back to the next one, so we have gone through this particular thing and everything else is done. Let's go to the next one. What is the next one? Node.js module, pretty simple one. I mean, what can be there? nvm ls, nvm, this is how you can just simply install Node.js. And unfortunately I do not have good network connectivity right now, such a bad thing. And fine, what have I done here? Import everything as arithmetic.js. This is just the file import and export stuff. Yeah, you can just simply import and export the file. There are two ways, CommonJS and ESM. Yeah, ECMAScript module. So you can just simply go with both. This is just the assignment, and yeah, no need to worry about this. So this particular section is done. Node modules, FS module, and networking. So let's go through this. If there's something that is worth having look at. There is something called ISP, Internet Service Provider. That's nothing but the service providers like Airtel, Jio and all. So temporarily assigns dynamic IP address via dynamic. One more thing, there are two types of IP addresses. One is static, second one is elastic. Static means I hope that's right. Static and dynamic, yeah, that's right. So dynamic means that is automatically assigned by the network. Static means assigned by a device or remains constant. So statics are mainly called elastic as well. At the end of the day, suppose if you buy an EC2 machine on AWS, so you get two options, whether to have an dynamic IP. So if you do not assign an elastic IP, so that's gonna be just a dynamic IP that just simply keeps changing. So if you tell me, what the hell, ले आएगा. So suppose what I was saying, that in EC2 machine, if you terminate, not even terminate, if you just simply stop that machine and start that machine again, so that machine will have a different IP address. Even in your mobile, if you just simply switch off the mobile and switch it on again, there's high probability that it's gonna have different IP address than before. So that whenever a machine starts, it is assigned a new IP address, that is the dynamic one. Static means the IP address will always be the same. So when it comes to having the same IP address, so you will be charged for that. So if there's any service, any company that gives you static IP addresses, same IP addresses for a same service, at that time of course you are going to be charged. And you need static IP addresses when you just deploy something. So suppose you are deploying a website, at that time you need to make sure that the IP address of your server is always the same, and at that time you need the static IP addresses or elastic IP addresses, and that time you are gonna be paid. Okay, never mind, let's continue. What is this? We are reading a file over here. What else? What are we doing over here? Let's just simply go through this particular stuff here. So import.meta.pathname, we are just simply reading a file. So import a file read from FS module. So we are getting the promiseified version of FS module, and once we have that, so read a file, and we are just simply providing it the path name. The question comes, how is are you gonna be creating the path name? So either index.html plus import.meta.url. So using this, you can .path name will just simply give you the path name. So it combines these both. So new URL and all. Let's try it out here. Why? I mean, just simply going through it will not make any sense. Coming back to this one, we have new URL, right? New URL. It takes two things. It takes the URL and it takes the base. What is the URL? Suppose the URL is index.html, and what is the base? Now import. It will not work here. Import.meta.url. Will it work? Yeah, it will not work. It will only work on Node.js. So probably somewhere here. So console.log import.meta.url. Again, this is not something that I'm gonna remember, so even if I forget it, that's fine. So what it does, it just simply gives me the whole path name. And if I talk about new URL and the file name, suppose index.html, and import.meta.url, just like this. If I just simply write again, so let's do it. Oh wow, what it does actually, it gives you the whole object, and that object actually contains the path name. So media to this. Interesting stuff. So you can get the path name. Good stuff. Again, you can make a Google search anytime that, okay, how can I get the path name using this and this? That's gonna be easy peasy. So let's not worry about that thing much. Something's wrong with my chat GPT. Let me just simply reload it. And apart from this particular thing, what is the thing that I have to worry about? There's nothing that I need to worry about. Next one is this. What are we doing over here? Even there is this thing, process.cwd. So it just simply gives you the current working directory. So if you want to know the current working directory and then have the file name, so this is also one of the ways. And that is it. There's nothing else as such. Object.entries.object, and that is it. The job is done. And yeah. Alrighty, 7 section is done. So I think we have gone through enough stuff. So at least this should be enough for now, till 7, and we'll be just simply keep going through the stuff as needed. As for right now, how long has it been? It's been 59 minutes. Good stuff. What are we gonna do right now? Most of the things has been quite theory part. So right now I wanna mainly start the debug section as well. I have to go through everything that I have learned, and these are the lessons. So let's start from here. The debug section actually starts from here, and let's do one thing till from week 24, right? So from here I'm gonna be just simply revising the stuff and all. So what is here? If 2 or more devices are connected to the same private network, okay, you can see the result of the running app or service in all the devices. That is right, using the IP address of the device which is running the program in the place of the local host. Remaining things are the same. So IP address 10.120 this, then 10.122.36. It will what is this, 236 and 236:3000. It will work on all the devices connected to the same network. So ultimately, if something is connected to the same network, so using the IP address of this one, you can just simply access it. Why can you access it? Mainly because if that is in the same network, and when you send the request, because that is in the same network, you will be able to connect it to the other machine. So yeah, that's mainly because of that. npx server serves the current directory. That is right. If you want to point a domain to a particular IP, let's go through it. It's gonna be fun. So beams deploying the MERN app notion. So at the end of the day, you have to go to hosts, and then you have to have this IP address over there. Will it work? The question is that. Suppose what can I say? When I write localhost, or what is the IP of the Google? Just a sec, coming back to this one. Okay, ping google.com. Do we get the IP like this or not? It should be ending soon. It doesn't seem to be ending. Never mind. So at the end of the day, this is the IPv4 address, if I'm not wrong. In that case, what can we do here? First of all, we can definitely go to this. So let's spin up this warp here. What have I done? Alrighty, clear, and cd/etc ls, and do I have bash rc file here? So I can just simply grep load. I forgotten the command as well. How to time to go through the command as well. It's been a long time. How to filter using grep. Excuse me, grep error, just like this. Grep bash.rc. It's not gonna make any sense. That's crazy, yeah. I should be able to find this right here. So we have this bash. So grep bash rc. Okay, never mind. Forget about this. LSA grep hosts. Literally, do we have hosts here? Yeah, we have hosts here. So cd host. As for the commands, I'm gonna be going through that command section very soon. So we are inside. Aren't we inside the host right now? cd hosts. That's not a directory. Okay, so we can cat it. So cat hosts. It is like this. So let's do one thing. Vim hosts and input mode. What am I actually do here? That so 127.0.0.1. if I say my localhost, will it work? Let's see. Let's simply save it. What the hell? This is the read only file. Let's just simply quit it first of all, and after that sudo vim hosts. Of course I need to enter the password as well. And now if I enter the input mode and enter mode, actually I have to just simply remove all these things. So script dd. If you double click d twice, so I mean if you just double click twice, if you double click d in at that time, it's gonna be just simply deleting the line. Anyway, let's just simply enter. So that's gonna be what I want, that 127.0.0.1, and it should be it should be referencing to my localhost. So whenever I write my localhost, that should be equivalent to this. Hopefully it's gonna work. Done. So if I say that I'm running something, what am I running? Nothing. So in that case, let me run this project. Meanwhile, I'm gonna be showing you the result as well. I worked on this quite a lot. Yeah, this is the one. There are many bugs that I have to just simply fix, but I've done more than I expected from myself. And of course there's a lot that we have to work on. This is sort of gonna be my interview project as well, so I have to give it my best. Anyway, that's cd app/web ls. Okay, now I'm not. Okay, coming back to this one, it will compile and just do the stuff. And this is how the revision goes on. It's not like you have to just simply revise one thing and then be stuck there. Whatever comes in your mind, just revise that, get the concepts clearer. Anyway, I was working on this thing so that whenever you just when this wheel event gets triggered, at that time your page just simply moves up and down. But the thing is that there were two logics just the same, so they were just simply conflicting. Hence I need to make sure that they just work on their own and do not interfere in each other work. That is something we will be taking care of very soon, probably. Again, the compilation. Congratulations. So this is something that's gonna happen. So let it compile. Okay, that's done. So this is how the board actually looks like right now. But functionality wise, it's pretty great actually. Like you can draw this, you can draw this, you can draw this, you can draw this, you can draw the line. Come on, you can draw the line. Hey, what just happened? Okay, nothing. Then you can draw this as well. You can draw the whole pencil. You can draw the text too. Hi there, just like this. You can even get up an image. This is not very structured yet, so I will be working on the logic, but you can definitely get the image. When you click on any image, this is the some kind of bug is here. I don't know what kind of bug that is, but okay, never mind. I think there's some kind of bug, but these properties section, that's not working yet, so I will be implementing that later. But overall this is sort of dynamic, right? Coming back to this, I wanted to make it my localhost. It is working. We have done it. Let's reload the page. Is it really working? Let's remove this canvas. Yeah, it is working. So ultimately my local host is actually able to reference to this ls cat hosts. What we did over here, that my local host should be referencing to 127.0.0 whatever. So this particular address, so it is able to just simply reference. So it is sort of a DNS server that I have on local machine. Pretty good stuff. So I'd like to switch back to localhost :3000. And one more thing, as I am already here, so let me show you all the features. So these features are pretty simple ones, right? But apart from these features, again I'm gonna writing, you can just zoom using this zoom in, and zoom out. Even you can click Control and V and you can zoom out like this. So this is also done. Using by clicking the mouse wheel button, you can just simply pan here and there. So this is also done. And so yeah, you can just keep it aside. You can start drawing more and more. So this is the thing that I have implemented here so far. Again, a lot of things are there to be implemented: database integration, even adding authentication, creating a lot of pages. So that's yet to be done. We'll even adding WebSocket. But yeah, good stuff. We can just simply zoom it here anytime. And last time I could not do it. This time I did it, of course using the help of AI and all. But at the end of the day, I learned how it's done. So this thing is done as well. What is the next thing that we have to do? We were just simply revising this stuff. We have gone through this particular section, and that's good thing. Cloud providers, we have different types of cloud providers. I have just simply explored only one of them, that is AWS, and that is it. Virtual machines, what the hell? Cloud providers, it should be loaded. DigitalOcean, Droplets. So DigitalOcean provides something called Droplet. AWS EC2. We will be spinning up EC2 instances as well. Command to connect to local terminal, SSH path, this, that is fine. You can even create, अरे भाई क्या हो रहा है? Just a minute. I know I don't have good network connectivity as well. So you can even create a config file inside .ssh. What does this mean? Yeah, these are the notes that I had someday. So we have these types of AWS cloud providers: AWS, GCP, Azure, CO, DigitalOcean, Vault. GCP is the Google cloud provider. So we have this as well, Google cloud provider. Even it asks for credits and all. So this is also, you can just simply explore. I'm comfortable with AWS, and that's sort of the most famous one as well. Coming back to this, what were we working on? This is the thing. I'm gonna do it in action. So the thing is that first of all, you can SSH into a machine like this. The another way is that you can even create a config file inside .ssh. Okay, like we can create that, and then host my EC2, host name, username, identity. So that's okay, that will work. To check if there are SSH keys saved, cd SSH authorized keys, EC2 instance, make sure the stop terminate, elastic IP, first associate with the instance. When the instance it is stopped or terminated, deassociate it and release it. This is easy to one, I mean easy peasy. So should I do it? I mean, I'm gonna be doing it in action, but okay. And apart from this particular thing, nothing. So let's do one thing. Let's do this particular thing in action. So AWS, going to create an EC2 machine on AWS. Then we will SSH into the machine using the normal command. Then we will create a config file, and then we will just simply run a command, and we will automatically be SSH. We will be automatically inside the machine. So this is how we are gonna be going ahead right now, and that's gonna be fun. And even we will, let's do one thing. Let's get an elastic IP address. I have credit, so I can do that. Coming back to this, let's keep it here, or let's keep it here at the end. That doesn't really matter. Hopefully it's not gonna take a lot of time. History, planning. One more thing, these are the logics. The world point is gonna be, because it took me a lot of time honestly to understand. Like on your screen, if you are getting the coordinates, they are the screen point. Then those screen points need to be converted to the world point, and they are the points of the canvas. And this is the overall formula. There is something called pan offset, scale offset, and scale. You need to know about them. Then only you can make a board like what I built. This is the formula. That's one of the bone or the backbone of the whole canvas. Without this, building the canvas is next to impossible. So finally I understood this. Coming back to this, I am username. What is the username? Unstop. Arey bhai, I should be getting suggestions, shouldn't I? I'm not getting. Unstoppable. The coder password is gonna be this. Sign in. Here we are on AWS. We have to go to EC2. We have to create an EC2 machine. I will even allocate it an IP address, launch an instance, and bro, अरे भाई cancel यार, I can launch it on my own. Right now we do not have any instance running, so if I click on launch instances, so this way we can create our EC2 machine. So I can say test EC2 machine, test EC2, and over here we can select an Ubuntu machine, and let it just simply load. Once that is selected, we can select the instance type, that is how strong machine you want, ultimately how many cores should be there. So in our case, 2 CPUs are gonna be there, 1 GB memory is gonna be there. We can even increase it, but no need. And we can select a key pair, that's gonna be Vipendra AWS, and that is on Mumbai, that is fine. Over here, let me just simply edit it. We have VPC. This was the VPC created by me, because the default one I deleted by mistake, and hence I have to enable this auto assign public IP. That simply means it will have the public IP, because if an EC2 machine doesn't have a public IP, you will not be able to talk to that machine. So we need to have it, and then the security group will automatically be created. The rules are automatically, this is the rule SSH, that simply means we'll be able to SSH into the machine, and that is it. Let's simply click on launch instance. The instance is gonna be launched. We have to go through a lot of stuff, even DevOps section as well, and we have to be really good at that. So by the way, this is the instance that got created. We have this public IP address. Using this we can SSH into the machine. We have this private IP address. This is mainly used for internal EC2 machine. So when one EC2 machine in the same network wants to talk to the other one, private EC2 instance, what network is used? IP address. And when you send a request to a server, so first of all you send using the public IP address, and then public IP address is actually converted to the the request gets the private IP address, and then only it will be able to talk to your machine. This actually everything goes inside VPC, that is virtual private network or of AWS. Let's not talk about that. But if you actually click on here, connect, so you will automatically get a command here, that is this command. What is this command? That is simply saying that SSH this, the whole command they are giving. We are not gonna copy and paste, rather we will write the command on our own. So let's copy this public IP address, copied, come back here. What I wanna do, first of all, let me go to ls cd downloads, because inside downloads only I have my key. So many days ago I created this key. Right now I have it. So using this key I'm just simply gonna SSH into the machine. If you remembered, when we were creating a machine, it actually asked for a key and we specified the key name over there. Sudo SSH, we are gonna be SSHing into the machine. Even I can say SSH, but I think it will ask for the name. But let's see, what is the key name? The key name is Vipendra AWS PP key. Okay, never mind. I think the PEM should be there. Never mind. What is the IP address? This is the what is the IP address? This is the IP address, and here we are. So we wanna SSH into this machine having this IP address. This is the name of the machine, and this is the credential that we are providing over here. And I think if I run it, I'll get an error. Yes. No. Yeah. Of course, I got. I have to mention sudo over here just for the root user. Root user right. Here we are. Let's write yes again. Now we are inside the EC2 machine of AWS, of course. And if you say which or what, who am I actually? Who am I? Honestly, I knew the Linux commands quite well, and then I forgot them. I was trying to go through a course of Ubuntu, Udemy, and over there the instructor actually taught good commands. So then it's been some time, so I forgot them. So if you actually go through this particular section, Linux commands. So these are the commands I have here. Probably tomorrow or someday we are gonna be going through all these commands. I need to go through them so that everything gets just simply cleared in my mind. These are the commands anyway. Similarly, this grep, I was just simply getting confused using this. So you have to just mention the name of the file and where that file is, or the current directory. I was unable to do it earlier, but now I can do it. How can I do it? Let me show you. Anyway, I am inside this. So ls if I create touch hi.txt, this file has been created. And if I say grep, and what do I wanna filter something that has something a text called text and in the current directory. Now what the hell, grep is a directory. How can we do that in inside a directory? Even there must be a command for that. Just a minute. Hi.txt grep hi in the current directory. I forgotten the commands literally. Grep hi, it doesn't work, stop it. Grep hi everything. Okay, never mind, I'd better go through this thing. I'm gonna be guessing it, that's it, nothing else. I think for directories we have this. Okay, so grep hi for the directories. Yeah, here we are. At least we got something. So something that has hi, so at least that has h, so we got this result. But this is in the current directory, so why am I not getting hi? It is inside the files it is looking for. So we have bash rc file over here, and inside the files it is actually looking for hi word over there. Never mind, we'll go through all these commands and then we'll have good command over it, right? As for right now, let's be okay with this. And the first task is done. What was the first task? That was SSHing into the EC2 machine. That is done, and let's just simply exit it. So we have exited the machine. And what was the next thing? cd :/ls. This is the folder. If I say present working directory, so this is the present working directory. And over here we have a config file. Now I don't know what's there inside a config file. Should I show you? I have some keys over here, let's ignore them. As for this config file, just a minute. How can I know this? Suppose, what is the command? New agent, control shift and this. Bro, what are you doing? Escape. I'm just forgetting the commands of this terminal as well. Okay, what does the config folder contain inside .ssh dir in Linux? Alrighty, do not check, bhai. It's gonna check. What the hell? I'll check content. It contains a config folder in this is a file, not a folder. So isn't a config folder in this? Let's do one thing. Cat. That's not a good thing anyway. Okay, it contains the same as expected. So host sudo and host name, identity, downloads. Okay, let's forget about them. This is the important step over here. There is a good thing. First of all, that host, the ID and the identity file and the username, and I think that's what I have here. So in my file, first of all you have to specify the name of the host, and we can specify the name anything. Then we have to have the host name, Ubuntu, and this, and we have to run ssh my ec2 and it will just simply start running. So let's do one thing, sudo vim and config file, and from here I think these can I delete them? Let me ask this. I cannot do anything without confirming. So where is the chat GPT? Is it okay if I remove them, or is there for the host? I think that's okay. Yes, you can remove the host sudo block if you are not using it. Your SSH config currently has sudo and this host. This, the first block is suspicious because host sudo is just an alias, named sudo. So host sudo means SSH will try to connect to machine literally called sudo. There is no user specified. It doesn't look like a valid EC2 configuration. So unless you intentionally connect using SSH sudo, you can safely delete and keep only this. Ultimately we can delete both. Now the question is, how do you select everything? So if I say dd, not dd, I am forgetting the commands, but okay, never mind. I'm gonna be just simply deleting them like this. Okay, I've deleted everything. Just keep clicking on dd and then everything's gonna be deleted. Coming back to this, what do we have to do? We need to have insert mode first of all. Host, that's gonna be test EC2 that we have created, and just below this, what are we gonna have? We will have host name. Hopefully that's right. Let me just simply have a look at this. We'll have host name, user, and identity file, and that is it. The job will be done. So we are gonna have host name. Is this how it's written, or that should be capital by default? Everything, it should be in the Pascal case. Okay, fine. So it should be host name, and that's gonna be the IP address of the machine. That is gonna be this one. And now we have user. User is Ubuntu, of course, Ubuntu, and we have what do we have? Identity file. Identity file. Slash download slash now I forgot the name. I mean ls cd downloads ls. What is the name of the file? This is the one. Let me paste it here, and I think everything's done. Let's just simply save it. Everything's saved. Now what will happen? Doesn't matter where I am, even if I exit this. Okay, I've exited that, and doesn't matter exactly where I am. If I run sudo ssh and test ec2, I am gonna enter the password, of course. Password why ssh ec2 or test ec2 sudo ssh test ec2. Why is that so? Could not resolve the host name test ec2. cd this dot ssh, or let's do one thing, cat dot ssh slash config. What do we have? We have test, we have the host name, we have this IP address. Is the IP address right? 243, that's right. We have the user Ubuntu, we have identity file. Have we written the identity file right? Downloads and new this right. Everything should be fine. Host spelling is wrong, sorry. vim dot ssh slash config input host. I mean spelling was right, but it should have been in the Pascal case. That's it, done. So now if I go to the root, if I go to the root folder, and from here, even doesn't matter from where, if I say ssh or sudo ssh test ec2 lol, test ec2 is temporary failure in the name resolution. You got to be kidding me, never expected to be stuck for this long. Slash config host test ec2. The name can be anything, right? And even we have named it the right, given it the right name, test ec2. The name should be anything, that's fine. Then we have user Ubuntu, and I'm actually in a hurry and keep making mistakes, and they're the sort of the most obvious ones. The thing is that it should be downloads. And now if I say ssh test ec2, probably we need to run sudo as well. If it asks for the permission, yeah, of course it will ask. So sudo ssh test ec2. Now it will be done. Sudo ssh test ec2. Bhai, what is the problem? This is the file name. The file name seems to be right now. Identity file, username. Test ec2 is the host name. Identity file. Downloads, this seems to be right. User Ubuntu, host name, this particular IP address. We have the host my ec2, we have the host name, this particular one, we have the user like this, we have identity file like this. It should be PEM. That's what I was mentioning earlier. Like we have two types of files here. The first one is PPK, and the second one is PEM. By default you get the PEM version, and this PPK I converted because earlier I used something called FileZilla. And what is the use of this FileZilla? That using the FileZilla you can connect to your EC2 machine, and now you can easily from your local machine you can copy and paste the files from your local machine to the EC2 machine. So I'll show how it's done. Even we'll go through it, as we are just simply revising this stuff, so we should go through that particular section. But before that, let me vim, and why am I doing it here? Let me come back here, and one more time I'm actually gonna change the name of the credential file, the token file, whatever. This should be PEM. And right now if I try to ssh test, even before that, sudo ssh test ec2, and दिक्कत क्या है भाई? हाँ, cat. I thought that was the issue, but gonna give this to AI, of course. Now enough of going through the stuff. What's wrong with this, bro? Tell me now. Where is ChatGPT? Here it is. Yes, this is a good SSH. If this is good, then why is this not working? Now you can SSH instead of this. A couple of optional things. We can have identities only. Yes, it should be working. It should be working. If it is not working, in that case, probably the IP address is wrong. But it cannot be wrong. 43250132243. Coming back to this. So we have 43250132243. That's the right one. Are we able to SSH into it directly? CD. Where are we? And sudo SSH www ppk or PEM Ubuntu @ the same IP address that we had over here. What was that? This is the one. Excuse me. Let's just simply paste it. Enter. Yeah, we are into the machine. So the question is, if I am able to SSH into the machine like this, why am I not able to SSH into the machine using the configuration? I think that is because there's only one option is remaining. That is, the way I have given it the space, the spacing is not right, and hence it is not able to. I think that's the only way that's remaining, right? I hope so. So what I'm gonna do, that is vim ssh I'm actually gonna control P, not this, yeah, input mode, right, and I'm gonna paste this here. Yeah, so there is extra space, and I think that's the only thing that can be problematic. I don't know about this, but let's see if that is the thing problematic. So we'll just simply 43.205.132.243 and here we are. Let's save it now and try to do it again. So sudo ssh and ssh, after that test ec2. Bro, what is the problem, huh? Instead of naming this my test, let's name it like this, sudo sh could not resolve host name test temporary failure in name resolution. Host name test, right? One more time, copy, and if it doesn't work, I'm not gonna stop, literally. ssh sudo test could not resolve host name sudo. What the hell? The first command that I had initially. Yeah, something that I deleted. I think that was the problematic thing. What did I give to AI first? That was what? Such a crazy thing I did here. This particular thing I deleted. It was here by default, and I think this this is actually needed. Probably this is needed. My bad. I thought it was the only thing that was missing, so didn't work either. Now the question is, how am I gonna be resolving this? And the answer is pretty simple. Why am I getting this error? Why fear when AI is here? The error is because your SSH config alias host test ec2 host name this, but you are trying to connect it to. अरे नहीं भाई, you are not getting it, bro. Now contains this, then connect with this, then sudo ssh test still doesn't work, check ssh test, you should see output like ssh g test. अब ये क्या है? Post test ubuntu this. So yeah, this is working. Check the permission. Could this be a problem here? cd dot ssh as lsa lsl and config has the this what permission does it need to have? So test with verbose logging, and should it only have read permission? What kind of permission should config have? The recommend permission is 600. That simply means only the main user can read and write. So chmod 600 in that. So in that case, ls change mode 600. 600 in the sense reading and writing. Okay. Config. Even this doesn't make any difference. I thought adding this would just simply resolve this, but it doesn't do anything as such. So in that case, I'm just simply gonna get rid of this. Something is wrong with my machine now, or with the configuration, because we are doing everything right. Time to what suggestions it gave earlier. Test without the config. We are able to. It works. Alrighty, sudo sh -b here. Time to give this all to the AI. Control Shift C. The log show the exact problem. Permission what for R2 open. This private key will be ignored. So the bad permission. Your private key has permission 664. Private. So SSH refused to use this because other users can read it. My god, literally. So the key is the problem. Seriously. The key should not have read and write permission. I mean, let me have a look at the permission of the key as well. It should only have which permission? 400, that simply means read, and 600 means read and write, just for the root user. ls cd downloads cd this ls cd downloads lsl. Here we are. So this particular key has these permissions, and that is problematic. Always I'm gonna give them change the mode. So the root user, R stands for root user, will have only write permission. Okay, never mind. 600 and read write both. That's gonna be for what? Depend on this pin. Done. LSL. Right now it has only read write permission just for the root user. There was another way of changing the mode, and that was user root. How to change? How to chmod? Chmod. This is the normal way, and there's another way. Options, mode, and file name. So not this way. Yeah. So plus execute and this. This doesn't make any sense. So chmod plus we are gonna be adding execute permission to what? Linux commands. Now where I have the commands, these directories, normal commands, grep commands, user commands, permissions, files. Yeah, this is the one. I think this is where it should be. And then below this I have this. So this is what I was looking for. So first of all we need to have the name, whether the group or the user, and we can even have, and then we have minus and the permission that we're gonna add. Let's try this thing out anyway. So coming back to this one, what we want here, that we have this permission, right? What I want, chmod root user, and we wanna add, what we wanna add, read, write and execute all permissions on this Vipendra pem file. Run this. Okay, that's invalid. Why? Chmod help. Okay, this was for the group, right? So we have for the group, okay, we have for the others. How about for the root user? Doesn't it give for the root user? Like for the group it will work. So if I run the same command for the group, so if I just simply replace R with G, it works. So right now group has all the permissions. It should definitely work for the user as well, but if I just simply remove G from here, then let's see. So root user should be, oh, it should be U, I think. Oh yeah, it should not be R, it should be U for the user in the sense root user. Come on, this. So read, write, yeah, that makes sense. So what I want that chmod, I wanna remove, so from the user I wanna remove read, write W, and let's remove from the group. So from the group read, write W will be removed, and read, write and execute will be removed from Vipendra and pem, just like this, ls l. And now if you actually have a look at this, so others have a reading, okay, so ls chmod others, they will not have read, write and execute permission. Vipendra pem -l. So now only the root user had read, write and execute. Even the root user will not have execute, just reading, writing is enough. So ls user, the root user will not have execute permission for Vipendra pem, just like this. That should be chmod. Now that is done, ls l, it seems to be alright. And having said that, instead of writing it like this, you can even say chmod 600, the file name is gonna be this pem, and the job will be done. Alrighty, whatever we had to do, we've done. Sudo ssh test, still failure. I don't know what all I'll learn figuring this thing out. So we have test, we have this, we have this, we have this. Even we have changed the permission of the file. In that case, ssh test should ideally work. Not ssh test. Sorry. How can I stop it? Skip. Control. Install ssh. Continue without installing. Literally, sudo ssh. That was the ssh test command, or sudo test. Ssh test. Sudo ssh test. So could not resolve the host name test temporary files with the name resolution. SSH test. Literally, why didn't I check this thing earlier? I'm already inside the EC2 machine. What the hell? Literally, yaar. This is my main EC2 machine. Okay, and if I say SSH test, install wrappers extension recommended. Okay, I'm actually gonna be inside the EC2 machine. Starting shell. Okay, that's fine. But here I'm inside the machine right now. I'm inside the EC2 machine. ls. Probably this is not that much well visible. So if I actually come here and SSH test, here I'm inside the EC2 machine. Lol, yaar. I don't know for how long there was nothing. The interface was exactly the same. So I just kept. But it just happened right now. Probably after editing the file of the permission, it just allowed. And apart from this particular thing, and I can say sudo SSH test as well, and it should be fine. Well, it is not fine, so I have to just say SSH test, and it will just simply bring me into the machine. And okay, that is it. That's what I wanted to do actually. So now how long has it been? So it's been 1 hour 53 minutes. Alrighty, so let's just simply call it for now, and I'm gonna be catching up soon. But before that, exit, done. We have to work on this as well, but okay, never mind. Exit. Alrighty, coming back to this particular section, we have gone through this section, we have gone through this. Connecting to someone's machine, this is gonna be insane, especially if that machine is in the same network. Then you can connect to someone else's machine as well. Unfortunately, I do not have any other machine, so we'll try this thing later on. But it's pretty simple. It's just that you have to get create the SSH token key, and then you have to keep the public SSH key in the config file. Authorized. What is the name? Yeah, so you have to keep the file inside authorized keys, and then you have to try to just access into the machine, and you will be able to access that. And this is what you have to do. AWS, we've done it. So yeah, the job is done. Congratulations. Whatever we had to discuss, at least related to this particular section, we have already gone through that stuff. So 24th is done. Then in the 25th one, what do we have? In the 25th one, this one, we have part 1 and part 2. We are mainly gonna be talking about the DevOps stuff, and yeah, we are gonna be going through all those things. I'm gonna take a break for some time. After that, I'll be back and continue from here on. Until then, bye bye, take care, and see you. Before that, let me close all these pages that I opened. Bye bye, see you, and I'm gonna be catching up soon.